Hey everyone, John with GSSI here to give you a quick walkthrough on carrying out a time mode survey using GSSI radar and Radan 7. Time mode surveys are an old school method for collecting GPR data from before survey wheels were commonly used. If you get to the field and find your survey wheel is damaged, or if you're like me and forget your survey wheel, or if you can't use a survey wheel, such as when scanning on ice or water, time mode surveying is still a viable way to get usable data back from the field. I've selected a transect for time mode measurement and stretched a tape 50 feet. I've placed flags every 10 feet so that I can drop a mark in my data every time I pass a 10-foot marker. I've set a SIR 4000 to time mode, which means it's going to continuously collect data at a constant scan per second rate once I start my line. I'll start collecting a line and begin pushing from behind the first flag so that I can accelerate up to a consistent walking speed. The less variability in your walking speed, the more accurate your results will be. The most important thing is to drop a user mark into your data every time you pass a flag. This will give you a reference point for normalizing your transect, converting scans into distance along the ground. Okay, here's our time mode line in Radan. You can see that we've got 6 distance marks, one at 0 and then one more every 10 feet. The first thing that we're going to do here is open up the tables and go to the waypoints tab down here. And this is a list of all the scans in our data set, as well as a table of whether every given scan had a user mark placed at it. So we're going to scroll down in this table here and find the first scan that has a user mark. That is scan 305 here, and that's our first user mark, so that is 0 feet along the line. We're going to set the distance at this mark to 0, and then scroll down to the next one and set the distance here to 10. And we're going to go down the list, and at every user mark we're going to set the distance that that user mark represents. So 20 for this one, 30, 40, and 50 for the last user mark. We don't need to worry about the scans before or after these user marks. Radan will get rid of those automatically. The next thing we're going to do is open up the file header. You can see here that we have a units per mark value of 0. This is what Radan is going to use to determine how many feet are between every mark there and stretch and squish our data. We've got 10 feet between every mark, so I'll change this to 10. And the only other value distance norm needs is this scans per unit value. So with this set to 18, Radan is going to try to convert this data into a distance measured line with 18 scans per foot. So the higher scan per foot value that you put here, the more stretched your data is going to be and the more interpolated scans Radan is going to have to create to put in there. We'll leave this at 18 and go to the Processing tab and select Distance Normalization. It read in the scans per unit and units per mark value from the file header, and we're going to set our marks to use to custom user because we're using user marks here, not distance marks. All we have to do now is press OK, and Radan is going to chop off the beginning and end of our data set there, the portion that was outside our transect, and scale everything so that we now have 10 feet of distance between every single user mark. Keep in mind that if you are using an older version of Radan, it might not work exactly like this. Radan was updated in version 7.7 to streamline distance normalization. So if you intend to follow this guide, make sure that you are on version 7.7. If 7.7 is still in beta when you see this video, update from the Help drop-down menu where we have this update option, and you will have an option then to update to the 7.7 beta.